So go to Structure 1. And as you can see, we need to remesh this structure. So select Create Mesh. Everything is fine. Then select Run this study. Now we are okay with the stress value. Let's go to the displacement. And here we have 2.8 multiplied by 10, which is 28 millimeters. Here I want to point to a very important point. Sometimes you lose the fixture. As you can see here, we have a problem. This point is fixed, but this one is not. And if you go back to fixed and edit the definition, you will only find one joint. That's why you need to select this. And now we are sure that we have these two columns fixed. Hit OK. Then select Create Mesh. Then run this study. Now the maximum value of the stress is way below the yield point, and for the displacement we have 19 millimeters of displacement, which is acceptable in our case. We can reduce the size of this column, but in some cases it's not only about the analysis, it's about the shape. So for this structure, the shape of this column and the size of it is okay, so we will keep it. Right-click Results and select Define Factor of Safety Plot. We need to plot the factor of safety of all the bodies, so we will keep this to all, and here keep this to automatic, and advanced, and under advanced options you have set upper limit for factor of safety. I don't want to see a factor of safety of 100, let's say, or something like this, so I will select this option and I need to see 4 as the higher value of the factor of safety. Then hit OK. And now here we have the maximum, which is 4. In reality, it's way more than 4, but I'm not interested in seeing this number. I'm only interested in the minimum factor of safety, which is this one, 3.1. And the weakest point in this structure is this one. You can click here, then Annotation, and it will connect this value to the location, which is here. Let's say we need to have a more accurate results. In this case, let's go back to the load here, edit the definition, and instead of distributing the load only on these beams, click here and let's add this bar. Then hit OK. Select Create Mesh. Then select Run this study. Now, as you can see, the stress were distributed in a different way, which is more accurate now. And if you go to the displacement, we have 1.8, which is around 18.2 millimeters of deflection. And for the factor of safety, the maximum factor of safety now is 2.8, which means the more details you add to the structure, the more accurate results you have. For now, if you want this to be perfect, you will need to add a plate here, and then you need to apply the load over this plate. But in our case, we are way beyond the yield point, which means that this is safe, and these analyses are enough to make sure that this structure is safe. The last point I want to point to here is that this shape you see is not real. This is just a representation of the stress, because we have deformed result. This shape will be the same. You won't notice any deflection, but this representation helps you to imagine the locations of the stress, and it helps you to imagine the locations of the displacement. So now, when I have this here, I know that the maximum displacement will be here, and it will be the same here. Let's go back to model, and now we are sure that the sections we selected are correct and can be used to design this structure. That was the first stage in the design process. Now we will start to design the real model that will be fabricated. Thanks for watching and see you in the next video.